Hello, everyone. Welcome to another episode of One Team TV. Basically, a series that talks about deployment of IT infrastructure really at a business level. It talks about challenges and outcomes and the sorts of opportunities that technology can bring. Today, we're talking about deployment of a high-performance storage solution at the University of Queensland and the associated research institutes. And I'd like to welcome two colleagues today to join me. We've got Andrew Beattie from IBM and David Cole from One Team IT. Andrew, welcome. Could I ask you just to introduce yourself for the audience, please?
Yeah, thanks, Con. I'm Andrew Beattie. I'm one of the technical leads for IBM storage for Australia and New Zealand, and I focus predominantly on high-performance computing, storage for big data and analytics type workloads.
That's great, Andrew. And David, quick introduction for viewers who haven't met you before.
Yeah, thanks, Con. Yeah, David Cole. I've been with One Team IT now for about 20-something years, focusing on sort of large IBM solutions in the enterprise space with both corporates and government/education customers.
Thanks, David. So today, guys, as I alluded to, talking about University of Queensland and the associated research institutes. Before we sort of dive into the solution type stuff, Andrew, maybe you could give us a high-level snapshot of what goes on at the research institutes that you do.
So yeah, Con, I guess, if we look at the University of Queensland, they are quite a large research institute and organisation. There's about 3,000 odd researchers. IBM works pretty heavily with the research compute infrastructure team, who provide the computing and storage platforms to allow researchers to deliver outcomes.
So, Andrew, what you're saying is the university was in a siloed environment from a point of view of infrastructure, with the consequent sort of restrictions and functional impacts that normally implies. Would that be fair?
Yeah, that's a pretty accurate statement. So, if you look at a workflow point of view, if you take an instrument such as a lattice light sheet microscope or an MRI scanner or any of those big instrument data collection tools, generally the data is scanned and captured to a local device and then copied from that local device, like a workstation, to a local storage array. It's then getting the data from that local storage array to where the users can actually do, or the researchers can do, computational analysis against it. Generally speaking, the instrument is not right next to your HPC cluster, or it's not right next to your analytics tools. So you then need to move the data from the local storage array to wherever the computational analysis tools are to allow you to do that analysis.
Okay. And just for people who are watching this who maybe aren't used to the sort of scale of data that we're talking about, can you give a couple of examples to illustrate the scale of data? Like you mentioned, big data before. Can you just give us a couple of examples and say what a microscope image might look like, or something from a size point of view?
Yeah, so again, it can vary depending on the type of research work doing, from maybe 10 or 15,000 4K files through to perhaps a full wide beam scan that might be 400 terabytes in size in a single run. So the size and scope of the data can vary very dramatically, but it also can be the costs of actually generating that data might mean that having the high performance storage justifies itself in terms of being able to capture all of the data in a single run rather than doing multiple runs. So, for example, if you do a lattice light sheet scan and you don't get a full beam scan, then each run is roughly $100,000 to $150,000 a scan. If you've got to do multiple scans to get a full copy of your data, then you're blowing $500,000, $600,000 to get a full set of the scan. If you can do that in a single run and capture all of the data in one go, you're potentially saving yourself hundreds of thousands of dollars just by being able to capture the data in a single run.
Okay, so you're sort of touching on business case stuff, which I was going to come to shortly. So hold that thought. David, can I just bring you in and ask you, like, your experience prior to working with the university was mainly around commercial and government and system of record type solutions. What was your impression when you saw the scale that was involved with the data that's generated by the research process?
Yeah, it certainly is a massive scale compared to what we've seen previously in the commercial market. And the other thing is that the size of the data that's been collected is just increasing exponentially. As Andrew said, some of these devices are capturing massive amounts of data, and that's not going to change as better instruments come out. The researchers are all clamoring to get better instruments, which then creates more of an issue at the back end as you need to transport, manage, and then do the computational analysis of that data. So it's at a scale beyond anything that we've traditionally worked with in the commercial space.
You're telling
That's
me
exactly
that
right. Every generation of instrument, it basically doubles the data set that you capture. So yeah, if you go from a Gen 1 instrument to a Gen 2 instrument or a Gen 3 instrument, then yeah, 2 times or 3 times the amount of data in every run. Yep.
And what you're saying is, compared to say a bank, you're probably talking about hundreds of times more data, if not more. Would that be right?
Yeah, so we have examples where we've moved a petabyte worth of data in a weekend. So in terms of the need to actually pick up data sets and move them to another location or to another computational area, it's not unheard of to pick up hundreds of terabytes or even thousands of terabytes and move them around almost in real time.
Yeah. No, fair enough. And again, to sort of help people sort of correlate what we're talking about with real world outcomes. Maybe David, you could start. What sort of practical outcomes is the research that we're talking about delivering to the community and to the world at large? What are the sort of things that you've seen or heard about?
Yeah, well, certainly, as Andrew said, there's a lot of different research projects going on at any time out at UQ and across the research institutes, and they cover just a very broad spectrum. Even if we just think about medical research, one of the examples that I like to refer to is the Alzheimer's research that's happening out there, and the performance and capacity improvements that we've been able to deliver over the last 3 or 4 years has had a very tangible benefit to the researchers, but also to the patients, where some of the workload is doing individual analysis of Alzheimer's patient to then determine a specific medication regime for them, and the faster that they can run the computational analysis of that data is then meaning that they can get through more patients in a shorter time, which has real world benefits for anyone that's suffering and the families of those Alzheimer's patients.
Okay, so the reputation of research boffins being isolated in dark rooms is not really the case here. Sorry, Andrew.
Yeah, so it's very interesting. I mean, one of the other use cases and one of the other examples that's probably quite topical at the moment is that the University of Queensland was very heavily involved in COVID research, not only in drug analysis and design, but also in testing. And while not necessarily one of the products created by the university making it to the market, they were very heavily involved in a lot of research work in drug analysis and design, and they have some very interesting tools in their portfolio in how to create new drugs and vaccines. So this is yet another example of the research that they do.
Okay, so real world connection and benefiting down to the individual patient is what we're seeing and what we're helping enable with the sort of the infrastructure solutions that have been put in place.
Yeah, that's certainly some examples. They also do nanotech, they do robotics and all sorts of other things as well. Some of the pure math research that they do, and some of the high performance computing jobs in terms of pure math is pure research rather than necessarily driving to a human outcome. But the ongoing net effects of that pure math research will be next gen technologies that will come out of it.
Yeah, and we know we can't get enough pure maths. We understand that.
The geeks of us certainly enjoy it, or get lost in it, one of the two.
That's right. All righty. So I'll come back to something you touched on before, Andrew, about the business case. So we're talking about a lot of a lot of investment required, both at the instrument level, and then to get the most out of that, the instrumentation. We're talking about something that might be regarded as prosaic, which is just storage. But there's obviously a business case. So it sounds like the business case revolves around not only the storage in itself, but getting a better ROI, both cash and outcome based, from this ridiculously expensive instrumentation. And I'm assuming the specialists that do the research are expensive people as well in terms of their time. Can you maybe outline a little bit more about how that business case works to rationalise spending hundreds of thousands, if not millions, on storage?
Yeah, so I guess again, this has been a journey for the university. They didn't just go out and buy millions of dollars worth of storage. They've bought incremental components and expanded the fabric that makes up their storage environment, starting with a single repository and then adding additional additional storage repositories as the need or the use cases has grown. So we started with their high performance compute cluster and showing them how that they could get benefits out of the Spectrum Scale platform for high performance computing. Then we added instrument data collection and data capture. Then we added in the user access and giving the users a common accessibility platform, regardless of where they are and where the data resides within the university. And each of those things adds a layer of business value. So, the simple one is, being able to capture a full set of data and save them money in running their instrument. That's a nice, easy business case to justify. Being able to turn around and run multiple HPC compute jobs in half the time or a quarter of the time, or maybe 10 times the number of jobs in the same time it took to run the previous computational job. That's a different level of business ROI, but it might translate into an even higher return on investment because you've got multiple different researchers achieving outcomes at the same time then. So there's a few different layers to that. And I think the university team has a very smart team in terms of looking at the problems that were key to their environment and picking and choosing the ones that were going to generate the most visible result for the university, and using that as the basis to justify the next step or the next investment. And the net result has been that they've been able to expand not only inside the university itself, but even collaborate with other universities and other research organizations. So they now use the same infrastructure to talk to other research organizations, not only in Australia, but also in the US and Taiwan and other countries, to actually share research data.
Yeah, so I think that's something that we sometimes forget, that what goes on here in Australian-based universities, elements of that are world-class and world leading, and leads to collaboration around the world on these sorts of challenges.
Absolutely.
So just moving on from that business case then, and again, for viewers who might think that storage is just storage, what are the unique elements of the IBM portfolio that the university recognised as being the right solution for them in your view?
So again, I'm going to be a little bit biased here because I like my products. So Spectrum Scale as a platform for unstructured data gives basically three things. First of all, it's a parallel file system, so inherently it delivers some technical benefits in terms of multi-access to the same files or to the same data that you can't get from distributed NAS or block storage technologies. The second part of it is the global namespace and the multi-protocol access. So not only do we support the POSIX capability, but your general SMB and NFS, object storage, even container-based architectures or Hadoop and analytics connectors. All of those are functions that are inherent within the storage platform, and that provides flexibility for users to access the data in the way that makes the most sense for them. Once you've got those base components in place, it's really about making the data accessible to the user at the right location. So whether it's next to the instrument where you're capturing the data, or whether it's next to the HPC which wants to consume the data, or whether it's into a public cloud so that researchers from other areas can access it. All of those things without manual intervention is where you start being able to differentiate against other platforms and particularly other storage architectures that don't have that level of capability. So, the caching architecture, I think the university would argue, is probably key to the success for them. The ability to have a single location or a single home repository that keeps a copy of all that data, but then have cached copies of it for high performance and local user access is really something that they couldn't find anywhere else in the market. And that's really what brought them knocking on IBM's door.
Okay. Just following on from that, David, I recall an exchange we had with the university where they talked about benchmarking the solution and the sort of outcomes they got and how they were a little bit surprised by the outcomes. Did you want to flesh that out for us, please?
Yeah, certainly. We did deploy a storage platform which had some clearly identified benchmarks that were required performance, and they were part of the initial contract. And the capacities is straightforward. The throughputs was where the focus really was for them. The benchmarks that were articulated as a success for the project were built based around the IBM documented capacities or capabilities of the Spectrum Scale hardware appliance. And lo and behold, at the deployment phase, the university decided they'd try and break the system and see what they could crank out of it. And the throughput of the performance was somewhere around 20% greater than the advertised benchmark. And UQ were blown away by that, not only because of the benefit that they would get for this platform, especially sitting in between these instruments and their HPC clusters, but also just knowing that there can be some truth in advertising with vendors. The benchmarks aren't downhill with the wind at your back at all times. It was a bit of a wake up to everybody to see that, which was an unexpected benefit.
Yeah, look, I guess my experience is that I've always been able to trust the fact that IBM published performance is exceedable in the real world, but it's rare that it gets tested to the extent and under the stress that the university put that solution. So it was good to see that validation. And I know from my point of view, the university expressed to me that they got a higher degree of trust in anything that comes from One Team IT or from the IBM as a result of that exercise. And that trust foundation just leads to a lot more collaboration, and that's an element of how teams work together in a high performance fashion. So that's been a really great platform for us to achieve even further outcomes with the university.
Yeah,
so
exactly right.
Absolutely. I guess.
Sorry, who wants to go first? Andrew?
Yeah. So once you start looking at projects of this size, this is really not a drop on the floor and turn on and walk away kind of an exercise. These outcomes are achieved by collaboration. You've got to work as a team and identify the components that you want to go after, the bits that you want to deliver, and the outcomes that you want to deliver, and take the journey and break it into steps that you can deliver outcomes from. It's the only way to achieve a level of success, similar to what we've achieved with the University of Queensland. But at the same time, it's not unique to University of Queensland. You can take this methodology and use it for enterprise workloads. You can use it for research workloads. You can use it for government workloads, as long as you understand that it's not just a drop on the floor and walk away kind of an exercise.
Yeah. Sorry, David, you had some thoughts as well?
Just around the capacities and performance. One of the things that we have been able to achieve for UQ is just removing some bottlenecks in their environment. As Andrew said, we've got some pretty intense computational work happening in the back end in the HPC cluster. We've got some very high-end data capture devices. I always say if you fix one bottleneck, you're probably likely to just create another one. What we've seen with our Spectrum Scale platform is that not only did they get a significant improvement in their capacity and performance of that storage layer, is that it's now enabled the HPC clusters to run at their maximum capability because the storage is now no longer the bottleneck, and that's
Yeah,
been and that is helping drive outcomes.
yeah. There's not much
And we
point
have
to
seen,
sorry, Andrew. There's not much point to HPC clusters if they're waiting at high speed. So
absolutely,
Yeah,
and we have
that's right.
seen the storage cause other bottlenecks in other areas, even to the net of needing to increase networking around the university and the university campus out to their home data center, because we were getting to the point that we were saturating their network links. Sometimes not to the happiness levels of the network administrators. Let's put it that way.
yeah. No, and
Yeah, exactly.
that's a good problem to have. Sorry, David.
Yeah, it's not very often that other clients of ours get 450 terabytes dropped on them on a daily basis, but it's not unusual that a researcher can dump or capture that sort of data. It doesn't happen every day, but yeah, it is a bit of a shock to the system, and the Spectrum Scale platform does allow us to ingest that data and manage it.
Yeah. No, it's certainly been a as Andrew alluded to, it's a journey, because I guess when we all started at 2015 with understanding the challenges out there, and that's where this all started, from my perception, is what's unique about the workload, what's unique about the challenges, what problems haven't the university and the researchers been able to solve with their existing investments. And I think from memory, it was a good 18-month, 2-year exercise to
Absolutely.
understand it well enough, where we could actually then articulate a solution that led to the sorts of benefits that we've been talking about today.
Yeah, exactly right. Yeah, there was a lot of what if we tried this and what if we did that and how does this work, in the first 12 months of just playing with things to understand how we would actually deliver an outcome that made sense for the university. And then even what hardware platform working with the software stack would actually make the most sense to deliver the outcomes. So the university went through multiple hardware stacks before they settled on the IBM ESS technology, and made that the standardized storage platform for their research data.
Yeah. I'm conscious of everyone's time, so I might just ask you both for your final thoughts. David, anything that you'd like to add that we haven't covered as yet?
Yeah, I guess from my perspective, looking from the outside in, what we've been able to achieve is really just build a platform for University of Queensland to leverage across these research institutes. So the Spectrum Scale software and the ESS appliances, hardware-wise, is the foundation, and it's critical to all functions of the research institutes, and it's given, I guess, confidence from university and the research compute folk out there that they can deliver time and time again for the researchers, which is what this is all about. And I guess it is a known entity for them when they are planning various projects with researchers. It's not very often that we have to modify anything to do with the storage platform. It's really leveraging the capabilities of the storage platform and what we need in front of that and behind it to deliver for the researchers.
Okay. And Andrew, any final thoughts or comments from yourself?
Yeah, I'd say that when we look at someone like the university, they are an interesting customer to partner with, because the things that they're trying to achieve are not necessarily the things that everybody else is trying to achieve. So some of their problems are interesting and different, but it means that we have the opportunity as a trusted partner to help them and show them ways that they can look at things differently, to open the box and look outside the box, or to one of the most common comments that I hear back from some of the people at the university is, "Oh, you can do that? We didn't realize we could do that with Scale." There's so many features within the platform that we haven't necessarily turned on, even in the university environment. So there's so many more things that we can look at and touch on as and when their needs grow and change. So the flexibility and versatility of the platform allows us to grow as they grow and change as they need to change to deliver their outcomes.
That's great. Thank you both. I guess from my perspective, standing one sort of step further away, there's plenty of clients and organisations that we've helped over the years to achieve commercial outcomes, loading the trucks earlier, getting the invoices out, running the payroll. It's been really, really interesting. And I know it's a big motivation from our team's point of view that we're not only are we helping achieve a commercial business case, better ROI on instruments, for example, but it's very satisfying also working on a solution with a client where there is actually a direct translation into a benefit into the community. And I know that's a motivation for us as well. So, gentlemen, thank you very much for your thoughts and insights today. Appreciate you both taking the time. To those viewing, our details are available to you through the invitation that you would have seen to access this webinar. Please reach out. David, Andrew and myself are more than happy to conduct a conversation or to articulate in further detail some of the things that we've been talking about today. Or if you've got particular challenges around storage and you want to tap in just for an opinion, please reach out. We'd welcome that. Thank you again for your attention, and look out for the next episode of One Team TV. Thanks very much.